Hi, Assalamualaikum. Today, me, Huzairy, and my friend Afiq will present to you about our physics assignment, which is physics in basketball. So this is the contents for our slides, which consists of 8 pages. So the concepts that we use in our physics assignment is projectile motion, kinetic energy, potential energy, and law of conservation of energy. So for projectile motion, it is a motion of an object launched to move in air under the influence of gravity. Assume that there is no air resistance. For kinetic energy is energy possessed by an object because of its motion related to mass and speed of the body. Potential energy, a change in potential energy equals to the work done producing it, thus have a definite value. For the law of conservation of energy, the total energy in any isolated system is constant, no matter what happens within it. Although the conversion of kinetic energy to potential energy and vice versa can occur, it must happen in such a way that the total is constant. The mechanical energy of an isolated mechanical system is conserved. So the objective of our assignment is first to study the projectile motion of a free throw in basketball. The second objective is to determine the vector components, the time taken, and maximum height of the ball in a free throw. For objective number 3 is to study the law of conservation of energy, and lastly to determine the final velocity of the ball using the conservation of energy. So for the theory and formula, the theory on projectile motion. The ball moves in a projectile arc. The motion of the ball is under gravity influence. The projectile motion of the ball can be analyzed by considering the x-axis and y-axis separately. The acceleration of x-axis is 0 meter squared, while the acceleration of y-axis is g, which is negative 9.81 meter squared. So the theory on the law of conservation of energy. The law of conservation of energy states that energy can neither be created nor destroyed, only converted from one form of energy to another. This means that the kinetic energy of basketball turns to gravitational potential energy and vice versa. Assuming that the mechanical energy of an isolated mechanical system is conserved. So the formula used, which is Ke is equal to 1 over 2 mv squared, and U is equal to mgh. So here we provide you a video of a free throw to give you a clearer vision on what we are working with.
I'm making a basketball appearance, but Julia is the baseball reporter for the Astros. Look like they're going to have a very good year coming up. I hope so. There it is, underhanded.
Oh, he makes it.
This young man was shooting terribly from the free throw.
So we have been shown a free throw video on the last slide, and we can make some calculation based on the physics that we have learned. So for these questions, they have shown us a player shooting a basketball into the net, and they have give us some information, for example the angles, height of the player, height of the net, and also the distance of the player with the net. So for the first question, given V initial is 7.15 meter per second, find the component of x and y with an angle given 55 degree. So 7.15 meter per second is the resultant velocity. So we can find the x component and y component with 3 go. So to find x component, we can times sin 55 with the velocity, with the initial velocity, and we can find the velocity of the x component. Then we can also find the y velocity of y component by times cos 55 with 7.15 meter per second. And for x component, the answer is 5.86 meter per second, and for y component is 4.1 meter per second. For the second question, they ask us to find the time taken for the ball passes through the rim and the displacement of the ball. So we already have the height of the ball when it touches the rim, which is 0.9 meters, and we can use formula S equal to ut plus 1 over 2 gt squared. And we will use y components here because height of the ball is y components. So just sub in the values and we will find times when the ball's at 0.9 meters high, and we will accept 1.01 seconds because it's the higher value compared to other values. And we can find the displacement of the balls on the x components by using the same formula, but we will sub in the x component value and we will get 4.141 meter for the displacement of the x component. So for the third question, they ask us to find the maximum height of the ball, assuming no air resistance. So we already have velocity of the y components, and we will use formula v squared to u squared plus 2gs and sub in y components value. So when the ball reaches the max height, final velocity of the y component is 0. So we will sub in all the values in the formula and we can find max height of the balls is 1.75 meters from the start point of the ball. But this question need us to find max height of the ball from the ground. So we will add up height of the persons and we will get max height of the ball from the ground, which is 4.75 meter. So for the fourth question, they ask us to find the final velocity of the basketball at the hoop. So we will use conservation of energy formula, which is kinetic energy plus potential energy. So in these projectiles, total energy of the ball is same at any points of this projectile. So we will compare it, kinetic energy and potential energy at the initials equal to the max height, equal also to the kinetic energy plus potential energy when it passes through the hoop. So we know when at the initials height, potential energy of the ball is 0. Then at the max height, kinetic energy of the ball is 0, and they are kinetic energy and potential energy when it passes through the hoop. So just sub in the values and we will find the final velocity of the basketball at the hoop, which is 5.8 meter per second. So in conclusion, physics has impacted our life in many ways. We had unknowingly used physics in our daily life, for instance, basketballs. By learning physics, we can learn the projectile motion of a basketball and the conversion of kinetic energy to gravitational potential energy. Therefore, we must learn physics so we can use it to create better innovations in our future. So that's all from us. Thank you.